All right. So I made a video earlier on, but I failed to proceed actually. So I have no option, but in this case, I'll just sacrifice. I need to do it in less than an hour, so I need to finish early. So what I'm going to do is now, I'll do it very fast. I'll do it very fast, such that we are just answering. This is not training. Yes, it's just a part of revision. Okay, so we're answering to sheet 2, I mean 5 of 2024-2025 academic year. So I'll be answering just within the given space. Okay, so it says an atom of barium has 56 proton and 82 neutrons. All right. So write the four isotope symbols. So an isotope symbol of an element will be written in the form of X. Suppose X, then with the mass number there, then the proton number. So these are the values that will be actually, this is a mass number, this is a proton or atomic number. So now having barium as the symbol, so we'll write the proton, which is 56, down there. Then now we need to find the mass, or you can just go on the periodic table and check. But in this case, we know the formula to say mass is equal to um, mass is equal to Z plus N. Okay, so this means that we have now mass that we are looking. So in short, we add the proton plus the neutrons. So we have 82 neutrons, then plus 56 proton, which will give us 138. So the 138 will sit there. So this is the nuclide symbol or isotope symbol. Then calculate the mass number. The mass number is the one just we calculated, 138, after adding all the thing we have there. Then how many electrons are in neutral atom of the iso? In neutral atom, they should be 56, unless if it has lost some to gain charges. But for now, it's 56. Okay, so bromine has two stable isotopes, which are these. Calculate the average atomic. So given average atomic mass of an element, given these pieces called isotopes, so we'll collect the average or the total mass of an element by saying the percentage given over 100, because a percent is always out of 100. Okay, then plus times again the mass given, then plus again the percentage given of that specific isotope, then over 100, always out of 100, then times the mass given. You get it? So this means that we have, okay, let me just do this. This means that we have the percentage given for this one is 56. Don't mind about the date, which is here, is 56. I mean 50.69. So you say over 100, then times the mass given, which is 79, of that. Then plus, again you do the same, you say 49.31 over 100 times the mass given, which is 81. So when you punch that on your calculator, you find something like 70. On my calculator here, it's saying, okay, 79.992. Okay, 992. You can try this. So that is it about this one. Let's go. Question 3. When something is charged like this, it means from just on the periodic table there, suppose it had a certain proton number there, then and also mass number there. By us having those, it means the electron has been lost, not the proton but the electrons. The electrons have been lost to by reduction of these 4 plus. Okay, so now determine the number of protons and electrons. So the number of protons, so these are neutrons, right? You just check on the periodic table for cyanide, selenium. You find that selenium has 50 protons. Okay, it has 50 there, somewhere there. Then the mass is 122 there. There is no need to struggle. I mean 112. There's no need to struggle. You just use a periodic table. These are just to practice. Otherwise, okay. Then the electrons now, you look at this proton number that you have. So the electrons has been given, 4 of them has been given. So the electron now total number should be 46 because they were they were 50, but 4 has been given as electrons. Find the mass number. The mass number we have already calculated as that 112. Then an isotope of osmium OS has a mass number of 128 and contain 116 neutrons. Just the same case. So we are told to calculate the atomic number. So it has a mass of this one and a neutron of this one. We use the equation mass is equals to proton number plus neutron. We have 16 there. It means we just subtract 192 mass is equals to Z plus 116. So when you group the like terms, you find that your Z will be equal to 76. So that's how you calculate this one. Then the nuclear denotation now, we write also as O, S. Then now we write the mass number there. The mass number is 192. It has been given there. Then the proton number is the one we have just from calculating, which is 76 like that. Okay, we have written the nuclide notation. This is the nuclide notation. So that is it. Question 5. Write the full electron configuration of the molybdenum guy. So this is what now, this one I have to teach you because you have to master it. Okay. This is how we write electron configuration. So I'm giving you this as a hint. So this is what you should be doing. So first of all, light. Have you seen the trick that I'll give you? We have S, P, D, F. Okay. So this means that I'll write these guys in this form. All right. So I'll believe so we can count 1, 2, 3, 4 like that. You have seen. So what I'm going to do is I'll write. I'm going to write to say I'll be going this twice. This side twice. Okay. So what I'm going to do is I'll say S twice. You have seen. Again, what I'm going to do is P now. P twice like this going this side. So I have to write P S again P S. Then now I'll start at D. You have seen. So I'll say D P S again D P S. Then I have F D P S again F D. Okay, I'll start from here. Then P S. Okay, just like this. So now I'm going to name this. So this one, this S is start at 1. You have seen there. So say 1S, 2S, 3S, 4S, 5S, 6S, 7S, 8S. So now I have also to count. I have also to count the P start at 2. You have seen. So I'll say 2, 3, 4, 5, 6. Okay, 7 like that. Then we have D now. D start at 3. So we'll write 3 there. Okay. So say 3, 4, 5, 6. Okay. Then we go to um F. F will start at 4. So say 4, 5. That's all. So each orbital like this S orbital looks like this. So it can only accommodate 2 electrons. Then P orbital looks like this. It has 3 orbitals in it. So it can only accommodate 6 because in each orbital 2 electrons should occupy. Then D electrons, it has 10. It has 5 of those 1, 2, 3, 4, 5. Then F, it has 7. Okay, 1, 2, 3, 4, 5, 6. It has 7 of them. Okay, so it means 14 should be there. Then here maximum is 10. Then here maximum is 6. So that's how they should be holding electrons. So this is 2, 6, 2, 6, 2, 6, 2, 10, 6, 2, 10, 6, 2, 14, 10, 6, 2, 14, 10, 6, 2. So these are enough for all your electrons. So you'll be just choosing to say, where are my electrons ending? Okay, so like for molybdenum, okay, so for molybdenum, it has 42 proton number. So the proton number is 42 there. Okay, so what we do is, I've shown you how these orbitals. I've shown you these orbitals, so there's nothing to worry. You know now what they hold. How many electrons should be there? The maximum electrons. Okay, so what I'm going to do is now, I'll choose, it has 42 like I said. Okay, so this 42 now will count. When you count there, you find that you end at 36. Okay, so what you do, we have 2, 4, 6, 10, 12, 18, 22, 20, I mean 30, 36, you have seen. So here 36. So this 36 can be used as a reference to cut adjust krypton. So 36 krypton, you get me? Then the rest now, the 4D and 5D will get the remaining electrons from 42. Okay, so that means that this is krypton going this side. It will actually get the value of krypton. So I'll use as krypton to represent these covered electrons going this side, okay, so then this is now what remains. We have 5s and 4d. Okay, so we have 4d and 5s. So from 42, 36 has been used there. So subtract. How many are you going to remain? You remain 6. So in that 6, in fact, it's supposed to be, yes, there was supposed to be 2 there, then here 4. But the electron should go there. You get here. It's comfortable to stay with one electron there, the s orbital, but it is filled with 2. So the one will be given to the 5s that actually is lacking. So 1, 2, 3, 4. You have seen? So we have 1 electron there, 2 electron there, 3, 4. So at least this one, there is repulsion. Every electron want to be free. So they are trying to fight. They are fighting to come here. So what will happen is S will give electron there and it will be there. So here we'll write 5 instead of 4, then here we'll write 1. So that will be our electron configuration. So that's how the electrons wouldn't want to stay 2. Just that they are forced. So here we'll say 5, then here 1. So this is the electron configuration. Done. So this trick that you have seen there, we'll be using it. I'll be just coming to this. So now that we know how to write electron configuration, so you can also be substituting pari. You use noble gases. Okay. So search more just how to write it. The other video where to write this using the trick, it was posted in the channel. Write the electron configuration for an antimon of SB using noble gas notation. The same one I'm from using, you pressing krypton, argon, stuff like that. That's how we write it. So for this one, I'll just go direct. In that I know that we all know how to write now the electron configuration. So you are going to realize that the electron configuration for SB atomon, it will be it has 36, 46, 48, it has 51 proton number. So what you do is you write krypton there, okay, then you have the remaining so krypton, like I said, it's ending here. If I'm to show you, let me just show you. Krypton ends here. Krypton ends here. So the last, the 5s, 5 shan, they are actually going there with the remaining electrons. So we'll have 4d here. I'm just using the d because of the way they are coming in the lowest energy n. So I'll say 4d, then, or let me say 5s2. Yeah, let me arrange it in that way so that you see. We ended here, okay? We ended here, okay? We ended here for krypton 36. Going this side, there are 36 electrons going this side. So what I'm going to do is I'll have 5s remaining there, 5s, 4d, okay, and d, 5p. You have seen? So here it has 2, then here it has 10, then here that's where there are 3 now, okay, just like that. So there are 3 because when you add 36 plus these 15 electrons, they are giving you what? 51. So what we do is now we are going to say this is the electron configuration. We are done. In short, we just say krypton there, then we have, you just lower, you put them in the lower energy level like that, okay? So say 4d because the energy level is 4, then 10, then we have 5s2, then 5p3. This is the electronic configuration in a noble gas way. So how many unpaired electrons are present? So we look at this last shell because everything is sealed. So in the p, you have seen p looks like this. I've demonstrated the orbitals. So 1, 2. So now there are 3. So 1, 2. They are not paired. They are just 3 in this p orbital. There are supposed to be 6 for it to be filled. So there are 3 unpaired electrons. So 3 unpaired electrons, like the electron configuration of cobalt 3 plus. So also this one, I'll be very fast. Now you just remove 3 electrons, okay? You remove from, specifically from, the 2 should be removed from any s which is available there. The s orbital which is available should be should be the electrons should be gotten from the s. So if we were to write this one now, okay, if I'm to write the electron configuration for this one, so for cobalt, this one I already know to say it is argon. It is using argon, which has 36. Okay, it is just about 36 in the. So this one is using 18 electrons. Okay, then the argon has electron configuration of 18. I mean proton number 18. So it uses that. Then from there we have 3 D and 4s for argon. So this means that if the electrons were going further like this, so this means that we had 2 there to make the proton number of argon. So the 3 were removed. So the 3 that were removed, it was from 2, and also here we had 7. Okay, the 9 one. So this means that if it is giving 2, first, I mean it is giving 3, first 2 should be removed from S. So this one goes. Then here will remain with the 6 because 1 electron will be removed. So this is the electron configuration. So we'll have argon, then 3d6 because the 1 electron has been taken. Okay? Hope this makes sense. That's how we write it. Then draw the orbital diagram. So this is how you draw the orbital diagram. You look at the NEs that you have. The highest NE we had is 3. So what I'll do is I'll say, or you can just bring the full electron configuration of this one. Okay. I'm tackling the other question. We need to draw for this one. So we are told to draw the orbital diagram for sulfur. Sulfur electron configuration. So let me check sulfur on my periodic table. Sulfur, it has the proton number of 16. Yes, 16. So what we do is we say S, S, P, S, P, S. Okay. D, P. I think we end somewhere there. So we have 2 there. We have 2, 6, 2. So it's making 12. 12 again, 6. It's making now what? 18, right? So we have 2, 4, 10, 12, 18. So these ones, they are not there in our in our um configuration of sulfur. Okay, so since it's not there, so this is the configuration that we have. Okay, so here we have 10, 12. Okay, so 12, it means we need diamond for it to be stable. Now remember we had 16, so here there will be 4. Okay, so you know what to put there. So now lighting these shells, you see there's one there, S, 2S, then 3S. So we have 2p, then 3p. You have seen that the highest now we can have is 3 as energy level. So I'll write n is equals to 3. Then here we have n, but this space is not enough for me. So allow me to write somewhere there. So we are saying n is equal to 3, n is equals to 2, n is equals to 1. So I'll look at what is in the first one as n. I only have 1s. So I'll write the orbit of 1s like that with 2 electrons filled because it is filled there. Coming to these 2. So we have there 2s with 2 electrons as well filled. Then in the same 2 we have also p. So we have p there. Okay. 1, 2. So you put now all the 6 electrons there, you pair them like that. Okay, it's not clear, but just to get the sense from it. So we have 3s and 3. So here under s again we have 3. So they are filled. Then the p now which is there is just having 4 electrons. So we'll fill them 1, 2, 3. The fourth one will pair there. Okay, so this is the orbital representation. We are done. That's how you represent on the orbitals. My handwriting is bad, but I promise I'll improve it. Just that I'm in a hurry. Okay, explain why chromium has the electron configuration instead of this one. Remember, see, there's the reason why it is having this electron configuration. It is because of um due to the stability of half-filled d subshell. Why? You see, the electron initially it was having these 2s, but it has given one there to be 5 at this point. So this means that the electrons can't be comfortable if they are just in like 1, 2, 3, 4. You have seen? This is the one it had at first. So just having in the d orbital, having the electrons, the 4 electrons won't be enough. Every electron will be fighting for this. So there will be is instability in this orbital. So what will happen is that it will borrow the 2 so that everything is equal. Now there's no confusion when you have both. You're working getting the same salary, but when someone is having the higher salary, then that will be confusion. So the reason is simple. The 2 will give 1 electron. That's why it has become 5 there. So the reason is due to the stability of our field d orbital for it to actually cause instability. So question 10. For the last electron neutral selenium said atom, write a set of 4 quantum numbers. So this one also need you to write actually the electron configuration. You can't just attempt this one without writing electron. So if I'm to write the electron configuration of this one, The electron configuration looks like this. This one you just have to write it. You look at selenium, it has proton number of 34. So if I'm to write the electron configuration, I'll have 1s, 2, then we have 2s, 2, then we have 2p, 6, then we have 3s, 2, then we have so ss, ps again, ps, p, ps, then dps. So all these should be in your head now how to write it. SP, you just look at that format, then you're coming back twice. So that will be p there. Okay, that will be 3p. Then that will be 4s. That will be 3d. Then that will be the p. Do you still have the p? 4p. Then 5s, but we just end at 4p. So this is the electron configuration. There is 4. Then here there is 10. Here there is 2. Here there is 6. Just like this. So you look at this now. We have this last energy level. Okay. We have 4p energy level. So we look at 4p energy level. Okay. So now this is what we do. These 4 quantum numbers, they are telling you the address of an electron. For example, you are in the house. Where in the house? In the room. Where in the room? On the bed, you see. So we have this one giving you the energy level. We have this one giving you the orbital. We have this one giving you the magnet, whether positive or negative. You get me? This one. Then this one, which is the spin angular momentum number, is giving you just a spin, whether the electrons was facing down or up for that specified electron. So what we are going to do is we'll say the 4 quantum number. You look at this, the 4 quantum numbers, this is the thing that we are dealing with. So the 4 quantum number n is already now 4. You get me? Then what happens that the AO is gotten by saying this AO there is gotten by saying n minus 1. You get me? That's how we get that. Okay. So, but there's no need at this point. But what we can do is the P. This is how they are presented. When L is equals to 0, that is S orbit. When L is equals to 1, that is P orbit. When L is equals to 2, that is D orbit. When L is equals to 3, that is ZF orbital. You get me? So here we can see there's P orbital. So meaning that L is equals to what? 1. Like they are relating there. So it's 1. Okay. Then this magnetic quantum number, it actually gives you the range of this, the same value of L from positive to negative. So we have positive 0 to negative 1. So this represents actually the 3 orbitals of P. You have seen? The 3 orbitals of P. This means that electron will be, there's a specified electron. The fourth electron can be here, but we'll see. So if we were to plot this electron, you'll find that these are values of ML. Okay. So what we do is we'll say the electrons, we can now fill them 1, 2, 3. Then here we pair them like this. You have seen it has faced it. By the way, we face them up like that. Then we pair them like this. So you have seen where it has fallen. It has fallen in this positive. So the value of ML, is equals to positive 1. It can be negative or positive, just like this. This is how it varies. Then the value of this one, for you to know magnetic spin. So this ms can be positive or negative, half. So here you can see it is pointing down. That means there is negative 1/2. It's facing. If it was up like the first one, it would have been just positive 1. So these are the 4 quantum numbers. So identify the orbital it occupy. It occupy the p orbital, these last electrons there. You find it in the 4 orbital, which is this one, in the 4 orbital, 4p. Okay, so that is it. So number 10, number 11. Arrange the following in order of increasing atomic radius. So if you check on the, as you go down, the radius increase because you are adding more shells. Okay, the periodic table, as you go down, then as you go like this to your right, you are adding more electrons in this, and it shrinks because the effective nuclear charge gets to be bigger because there are a lot of electrons, and the effective nuclear charge is a charge experienced by valence electrons, these electrons in the outermost shell to the nucleus. So the effective nuclear charge is the charge experienced by these valence shell to the, so as you increase, the charge also increases, because, and it will reduce the radius because it will shrink because of the force that is getting bigger. You get? So that's how, as you go to your right, it reduces, but as you go down, it increases because you're adding more shells. But as you go light, you're adding more electrons in the same shell, so that maintain that reduces the radius. So now arranging these guys in that trend. Remember, we are attack this one we have already tackled. We know now the set of quantum numbers. Wow. Okay. All right. So arrange the following. So if you are to arrange these ones, chlorine is actually having more. Chlorine is having, it's in group 3. Okay. So then magnesium is in group 3 as well. But as you go, chlorine is this side, so meaning that it will be raised. So here, this is how we arrange. So we have chlorine first, then followed by selenium, this one, this sulfur, I mean sulfur. It is also in group the same of chlorine, but sulfur, it is somewhere here, it is somewhere behind than chlorine. Like I said, as you go like this, it shrinks. So sulfur will be at least, then um followed by aluminium, then followed by Mg. So the explanation that I've just given is enough to say, as you go this, when you check which one is to the light of the two given, again next, which one is the light as of the two I'm comparing, just like that. Then the first ionization energy of these three elements are, so for ionization energy, you need to look at ionization energy, you need to look at so ionization energy is the energy required for an atom, gaseous atom, to lose an electron. The energy gained, or the energy associated when an atom release an electrons. It can only release when it is in gaseous state. Okay. So here, the way to increase, have you seen this number? This number there. Okay, it's bigger, then followed by this, then followed by this. You see? So this is how they will increase now. So the first analyzation, where's the question? Identify element what and what. So here, this is how we can actually identify them. You can tell by saying this is the periodic table, right? These electrons, these atoms that are there, they are actually um they have they release an electron easily than these ones which are this side. Okay, this side are lacking electrons, but these side ones, they need like a element of group 1. Okay, so the way we tackle this is the highest here. If you can see in the on the periodic table, if you check um this one, aluminium, okay, it is giving +3. Then magnesium, it is giving +2. Then sodium is giving +1. You have seen. So this is how we'll be identifying them. Sodium has high electron because it's not easy to remove this one electron which is there. But when there are two electrons, you can remove them easily because there is repulsion. So followed by this, you have seen. So what I'm trying to say is these three here, aluminium will get the highest. Then followed by magnesium will get this one. Just like that. So the more, so we are saying now sodium will get for it will be the least. Okay, so it will get this one. Okay, so these are the ionization energy. You look at which one has a lot. Okay, so that is it. That's a trend given here. So sodium will be given the least, which is 496. Then magnesium will be given 738. Then aluminium will be given 1251. Okay, that is it. Then explain why fluorine has a lower electron affinity than chlorine despite high electronegativity. This you can find it when you draw the electron configuration of the two. You will see the comparison in the change of electrons that remain in the last orbital. So the reason that you can give is that yes, it has, due to the repulsion um, in the in the electron configuration of 2p of F. You see, just draw the electron configuration, you find that there will be an electron in the chlorine remaining than in the fluorine. So that increase actually the electron affinity. Okay, affinity is just the love or the love of an electron. Okay, so the reason I said um it has lower electron affinity than chlorine is because of repulsion in the in the configuration of 2p orbit of fluorine. So just check, you'll be able to verify. Just check. I can't write the electron configuration. Just compare the electron configuration. You find that the other one, this F, it is somehow stable in the way electrons are situated than this. So it will be, this one is more stable than this. So you find that where it is stable, it is hard to remove an electron than where it is unstable. Okay, arrange these species in order of decreasing size. So the size decreases as follow. So if you have more negative like that, okay, so the increase in the negative in the size of these ion is by the higher the negative, then the higher the charge. Okay, so if I have -2 is greater than -1, again if -1 is greater than 0, again this is greater than 1, again this is greater than 2. You have seen? So that's how we increase them. So you just start listing by saying this one with the -2 there is more high, so it's decreasing like this. Then we have again fluorine with a negative there. Then we have you look at the charges that are given there. So we have neon now. Is it neon? Yes. Then we have now positive. We have sodium plus. Then again plus. By the way, these are plus and this is plus, just for demonstration sake. So we have Mg plus 2 like that. This is how they decrease. Okay, the size. So the more electron, it means it's more like you have added more electrons there. You have gotten more electrons here. Here again also you have gotten. Here not that much. Here you have given. Here you have given. That's the reason why it moves like this. So provide a trend based rationale. So as the charge increases, as the charge reduces, the charge here reduces, then the actually size of an electron increases. So because you are adding more electrons, you are bringing more electrons. So the size increases because you are gaining more electrons than giving. When you give, then you are removing these shells. That's a trend which is there. Arrange the following in the order of increasing metallic. So if you check these ones now, if you check these ones, this is number 15. So if you check these ones now on the metallic part, you look at you use the periodic table to identify these. Okay, so you can't just identify by eyes, but you check using the periodic table. So how do you check using the periodic table? You go there and check on the periodic table which one as you go to this, the metallic reduces. As you go to this, the metallic increases because more metals are earth metals, alkali earth metals, group 1 and group 2, then followed by transition. Those are more metals. Okay, then going to group 4, 5, 6, 7, they are becoming metalloids or they are becoming gases. So explain using periodicity concept. So that's the explanation that I'm from just saying. Then this is how we group them. If you check on the periodic table, lithium is more collector. Okay, so arrange the following in order of increasing metallic characters. So this is how they will increase. So lithium is not that character, or it's not that because they can be easily be cut with knife. We learned the properties in grade 8. So it will be followed by potassium, then it will be followed by rubidium. Okay, then it will be followed by calcium. Okay, calcium. So um calcium is more because as you go down, you are increasing even the boiling point. So the metallic increases. You are increasing the shells, hence you are also increasing the character or the boiling point of something. So that's metallic character increases. So that's the explanation you can give there. Verify with me on the periodic table and see what is happening. Okay. So an element has the following ionization energy. So we have these ionization energy: first ionization energy, second ionization energy, third ionization energy, fourth ionization energy, and fifth, just fourth. Identify the element and explain the jump between E2 and E1. So if the way you can identify this element is um so the jump between E2 and E1, so the jump between E1 and E2, if you subtract this, so E1 and E3, E2 and E3, you subtract that, you find a certain value. So the jump, okay, the jump that is there is due to the um let me just subtract something. Let me subtract this. Punch on my calculator. Okay, so we have 1000, then minus 492. So there's a difference of 3000. Is it the same? Yes, 3000 something that. So that actually shouldn't be a worry. So the jump is likely to be, so these values, by the way, they are not even that important to you, in that they are actually, there are no periodic table which provide the electron negative, I mean ionization energy. This was just given to elements. So identify the element and explain the large jump between. So the element that actually will be holding this is probably group 2. Why? I know the trend myself. So this is probably group 2 and magnesium somewhere there. This is the way it goes. So by the way, what I'll do is between two, just the point they mentioned between two, it means just know that the element should be in group 2. Okay, between two, if it was this one, it was, you look at the initial where it is coming from. Okay, before it ionize, so it is coming from group 2. Even here, if it was here, it was ionized. So what I'm trying to say is, if it is from group 2, it means it's giving 2 plus. If it's from group 3, then 3 plus. Okay, so you can identify the element here. You choose any element, you just likely, if it was 3, then that would be aluminium somewhere there. Then here it's magnesium mostly. Okay, identify the element and explain the jump between this one. So to explain the jump is because of um the element is in group 2, like I said. So the likely is the jump, just the jump, it tells us, like I said, it tells us the group where the element is likely to be found. So the element is likely to be found in group 2. You look at the initial. Okay, so 17, so that's what you should tell now. Should be magnesium there. You just look at where it is coming. If it was E3 and E2, E4, then the element would be somewhere aluminium from group 3. You look at where it is coming from, the jump. So identify the element in period 5. This is simple. So identifying the element in period 5, group 15. Group 15 is same as group 5, by the way. Period 5, we should know that. So if you look at on the periodic table, you find that the element that is being talked about is um, the same antimony, which is the SB. So the antimony, you check on the periodic table, SB. Just use the periodic table, you'll be able to see this, what I'm talking about. Then light its electron configuration. So the electron configuration we have already now range. So it has krypton. So demonstrate what I was just writing, or look other sources to actually find out to write electron configuration. So it will be 3D, 10, then 5s, 2, then 5p3. Why? It's because this krypton, it is having actually 36. So 36 has been eaten up. Then you add 36 plus this, you find that that will be 46, 48, then 51. So we have 51, like I said. So this is the electron configuration. We wrote it previously. So this is the electron configuration. Okay. So use that table I gave you, you'll be able to write these ones. Then substitute, just I've just written. Classify, is it a metal, non-metal, metal? When you look around the periodic table, the same mentioned the atom with the 51 proton number, that is SB. So this element is actually a metalloid. Okay, it's a metalloid. Just check that zigzag line on your periodic table, you find that it's a metalloid. Okay, so that is it. So coming now to question 18. Question 18 is saying, so question 18 is saying, okay, question 18 is say identify the element. When you check at this element, you just master. This is what I'm from writing, in fact. So the element here is the same antimony. Okay, antimony, SB. Then identify the element, it's antimony, SB. Then it state its period and group. So the period we already they gave us, it was 5. Then the group, it was should be 5 as well, 15, which is 5. Then the broke, what is the broke? Is it the PD? Okay, so I'll leave that one. I'll leave for you, but the group is P broke. So you look at where it is coming from. Okay, so the group like this, these ones they are D broke. Okay, this is D broke, then this is the S broke, this is P broke. Okay, that's how they are classified like this. So that is it. Then predict its most common ion charge. What charge can it be giving? What charge can it be giving? It's coming from group 5. All the group 5 electrons, they lack 3 electrons. Okay, so the charge that it will be giving is -3, like that. Okay, that's the charge it will be giving. Then 19, as the police officer was lighting up a speeding ticket, she mentioned that there was using a state of the art ladder gun operating 335 gigahertz. What is the giga, by the way? Giga, this giga just means 10 to the power. This giga 10 to the power 9. So we have, these are the units for frequency. What is the wavelength? So we have this governing, which is equals to speed, which is c. So this is the equation that govern these radiations. So we are looking, they are asking us to find the wavelength. So we divide. So we have wavelength now is equals to c over f. So we have now the speed of light is 3 times 10 to the power 8 meters per second, but I won't write the meter, I'll just write the values. Then the f now, which is the frequency, like I said, it is 35.5 times 10. Giga is 9 to the power, so that is the hertz. That's the frequency. So that will be now the SI units. I mean the value now, if you punch on the calculator, you find something like 8.45 nanometers. Okay, so 8 you can take in nanometer. We know how to convert these prefixes. So the value there, it will be 8.45 nanometers. Okay, I've really made a mistake because of the same nanometers. Okay, so that is 12 I'm sorry, we have already tackled all these. We have explained all this. We are almost there. Don't worry. 18, 19, we are here. So when you punch there, I said you find something like 8.45 nanometers, like I said. So you find something like 8.45 nanometers. Okay, so that is it. That's how you find this. Always wavelength is measured in meters. So to calculate the energy level required from to calculate the energy level, question 20, to calculate the energy level, so the energy level will be given, change in energy will be given as Planck's constant. Okay, so there's a value we put there under Planck's constant. Okay, so the value that we put there is negative. Let me just give you the value, negative 2.178 times 10 to the power negative 18. I mean 8 to the power negative 8. Yeah, just have to master this one if at all you are told. So to the power negative 8. Then this is in joules. The Planck's constant is of joules. Sometimes you'll be given in each session of paper. So the formula is given as n final squared, then minus again the n A level initial, then squared, like that. Okay. So what we'll be doing is we have 2.178 times 10 to the power negative 8, open bracket. By the way, they are joules. We are intending to have energy, so which is joules. So we say 1 over the final energy level is 3 squared minus 1 over the final, the initial, it was 2 squared, like that. So when you punch that on your calculator, you find something like 1.89. Okay, so joules should be joules. Just verify properly with calculator, press it slowly, simplify this part slowly, then punch. So you can simplify this part by saying we have 1 over 9 minus 1 over 4. So that can be, you multiply these two. So you find something like 36. 36, then that, this time that, you find to say should be negative 9 minus 4, which is negative what? Remember it was negative, that's why positive, it's giving positive. So it's negative now 13 over 36. So there is negative there. So you multiply that negative times this number there, you get positive. That's why it's positive there. Okay. So besides that, you have joules there. That is it. So I was just for demonstrating. Otherwise, you really need to perfect, get what I'm saying, get the knowledge, then try it on your own. So after I explain, then try to punch also on your calculator, get what I'm saying, like light somewhere there. That's how we go about this. Otherwise, that is it for tutorial sheet. That is it for this tutorial sheet. Otherwise, if there's any question, let me just give a contact there where you should inbox, so that I explain using a VN, using a voice note. Otherwise, more tutorial sheets to be done. I'll send more tutorial sheets. Okay, I'll send a lot of them. Otherwise, that's how to go. Like each questions, what I've explained, then you do it. Light somewhere, get just the knowledge that I've given on each question. Then you'll be good and well with everything. These are just for practice. They might just get maybe 1 or 2 questions from these. Otherwise, we really need to know. There is nothing hard in this one. Everything is simple in this paper. So that is it. Okay. Thank you very much. So the number that I said now to say you can use this, it's this one. Okay. You can use to, like, for example, you are not clear of anything and you need the explanation. So 0964 122 411. So alpha, that is it. Thank you, Tactic Academy got you.